emissions are making waters like these more acidic. When the waters become acidic, organisms in the water can't get the nutrients they need to produce their shells.
The same CO2 emissions contributing to climate change are also contributing to ocean acidification. The ocean absorbs about a third of the CO2 released into the atmosphere each year. When CO2 is absorbed by seawater, chemical reactions occur that reduce the pH, making it more acidic. This process has many harmful effects on life in and out of the ocean. The Industrial Revolution started the release of carbon dioxide from factories and machines. Since then, the oceans have experienced a 30% increase in acidity. At the rate we're headed, oceans could be 150% more acidic by the end of the century. At first, scientists thought acidification was beneficial because it helped regulate global warming by taking carbon dioxide out of the air to counter the greenhouse effect. But the slowed warming comes at the cost of marine life.
Continued ocean acidification reduces the amount of available calcium carbonate, which makes it hard for organisms that need calcium carbonate to produce shells and skeletons, such as oysters, clams, sea urchins, corals, and more, to make and maintain their protective casings. Without their building materials, these shells will break down and organisms will probably die. This would have a devastating effect on the food webs of ecosystems, since there would be many organisms losing their food source and others that will take over in the absence of predators. More than 1 billion people rely on food from the oceans as their primary source of protein. If they can't get that protein, that means 1 out of 7 people has lost their source of protein. According to a new study, massive volcanic eruptions 252 million years ago caused large-scale ocean acidification, which triggered the largest mass extinction in the history of life on Earth. The Primo-Triassic boundary mass extinction occurred over the span of 60,000 years and wiped out more than 2/3 of land species and over 90% of marine species on the planet. There were 2 phases in this extinction. The first was slower, occurring over the course of 50,000 years. The ocean pH remained stable due to the slow injection of carbon into the atmosphere, but it led to the second phase, which was rapid and a large injection of carbon, which caused an abrupt acidification event that led to extinction. Carbon emissions today aren't as massive of an influx as this mass extinction, but they are being injected into the atmosphere at a similar rate. A high rate of carbon injections, not just the overall amount, was and is a big part of the problem because it leaves species with little time to adapt.
The pteropod is a small, shelled organism about the size of a pea. They serve as a food source for krill, whales, and juvenile salmon in the North Pacific, among others. The picture grid shown shows what happens when a pteropod is placed in seawater with the pH and CO2 levels predicted for the year 2100. As you can see, the shell dissolves within 45 days. In March 2012, multiple different federal agencies drafted guidelines for research and monitoring of acidification. These guidelines for research focused on issues with human and economic consequences. You can help slow the effects of ocean acidification by reducing your carbon footprint. Try drying laundry on a clothesline instead of in the dryer. Walk, bike, take public transportation, or carpool to your daily destinations. Replace light bulbs and older appliances with newer, more efficient models. Depending on where you live, try to use alternate power sources such as geothermal, wind, or solar. Not all energy comes from burning fossil fuels.